Welcome to the Power BI Layered Map Grand Tour video. This video will demonstrate the major functionality of the Power BI Layered Map visual, including displaying multiple WMS and WFS layers on a single map, as well as customizing the Power BI layer to adjust color, size, labels and images based on data values. Let's start by adding the layered map visual to a report page. The visual requires data from Power BI in order to function. Let's add the latitude and longitude fields from Power BI. By default, the fields may be added with some form of aggregation such as average or sum. Let's remove any aggregation by selecting Don't Summarize for both latitude and longitude. Notice that the map controls appear on the left of the map. The plus and minus buttons allow you to zoom in or out. The bearing pitch button allows you to change the bearing or the pitch of the map. To reset the bearing pitch to the default view, set the pitch to vertical, and press the bearing pitch button to reset the bearing. You can also zoom in or out by using a mouse scroll wheel or by pinch zooming on a touchpad. The settings button is the entry point to configuring the visual. Let's configure this map to show our Power BI data as points on the map. Let's start by retrieving our license key from the website using copy and paste. Notice that by default the map has a single layer called Power BI Data. This layer displays the data from Power BI. Other layers will be added later on. Let's change the name of the layer to World Cities, since the data coming from Power BI is a data set of cities from around the world. Layers can be displayed in a folder hierarchy for better organization. Let's place this layer inside a folder called All Layers. The Power BI layer is a point layer that requires WGS84 latitude and longitude fields to render. Let's specify which fields from Power BI are the latitude and longitude fields. Close the settings screen to submit the configuration to the website. The website will compile the map configuration into an application that will run for all users. Notice that one more button has been added to the controls on the left. The tree view serves many purposes. It displays all folders, layers, groupings, subgroupings and properties in a hierarchy structure. Levels of the hierarchy can be clicked to zoom the map to only the relevant features. It can also be checked and unchecked to show or hide features. It also serves as a legend for map configuration such as color or size meanings. Now let's explore some of the high-level configuration that is possible for a map. The base map imagery defaults to OpenStreetMap, but can be changed to Bing Maps imagery by providing an API key in map type. The base map can also be changed to a solid background color for situations where background imagery is not appropriate, such as presentations. Let's reset our base map to the default OpenStreetMap imagery. Now let's select an area of interest around Western Europe. If we want the map to default to this location instead of 00 latitude-longitude, we can do so by clicking on the Set Bounds from Map button. Notice that by default we are able to pan and zoom away from our initial location. We can restrict users to this initial location by setting pan behavior to restrict. Now the user cannot pan away from Western Europe, even after zooming. We can restrict the user's location even more by setting Allow Zoom in to false. This creates a map where no panning or zooming is allowed. Let's reset the pan and zoom behavior to their default values for the rest of this demo. Now let's examine how the layered map visual can interact with other visuals on the report page. Let's place the layered map visual side by side with the table visual with country and city columns. We will configure our map visual to filter other visuals to only those data points currently visible on the map. Notice that when we zoom in on an area, only the features visible on the map appear in the table on the right. We can also use Alt left mouse to draw a selection rectangle. Individual features can also be clicked to select. Oppositely, the layered map visual can be filtered from other visuals on the page. Notice that as rows are selected from the table on the right, the map filters and zooms to only show the selected data points. Let's now add some more data from Power BI into the layered map visual. We will use this data to drive different appearances and behaviors inside of the map visual. Some layer types, such as the Power BI layer or WFS layers, support multiple groupings per layer. This allows users to view the same data in different ways simply by toggling from one grouping to another. Since we added the country field to the visual, we can now filter the Power BI layer grouping to only show cities inside of North America. For this type of filter, the filter designer is the best option. The filter designer allows users to create groups of logic on field values, and provides auto-complete multi-select capabilities for equality and inequality. It is also possible to create TypeScript expressions for more complex filtering. In this example, we filter to only show country capitals. Filter expressions must return true or false to determine whether a data point should be shown or hidden. Autocomplete will provide all field names available for use in the expression. While this expression is relatively simple, in a later example, a TypeScript function is used for more complex expression logic. As you can see in the tree view to the right, by default all features are placed inside of a single subgroup called All Items. Let's configure these city features to be grouped by country. Here we will clear the filter expression to show all cities from the dataset. Here we will choose single column because we want all cities to be grouped by a single column value, their parent country. Now all features are grouped into country subgroupings. Each subgrouping can be separately checked or unchecked, zoomed into, or expanded to show its features. Feature names default to their feature ID. Let's change the feature name to be more informative. Now we can clearly identify the features inside each subgrouping. Now let's explore the different means of changing features' fill colors. We will start by simply changing all data points' fill color to a shade of red. Now let's change the fill color configuration so each country is randomly colored separately. Because the tree view also serves as a legend for property values, let's change the legend title to be more descriptive when viewed in the tree view. As you can see, the fill color property now presents itself as a legend of each country with its associated color. Now for a more complex example, let's use a TypeScript expression to color each city by its starting letter. All fill color examples so far have used random coloring. Let's now switch over to creating bucketed coloring. This next example shows all cities in the Northern Hemisphere grouped by climate type. The northernmost cities are in a frigid climate, while the southernmost cities are in a tropical climate. In between these two climates is the temperate climate. The tree view will display all bucket values with their associated colors, as well as discrete color buckets. Continuously colored buckets are also possible. Here we color all cities by their distance to the equator, where blue cities are furthest from the equator, and white cities are closest. The tree view will update to show starting and ending colors and values. Buckets can also be created from TypeScript expressions when values do not exist in the Power BI data. In this next example, we will color each city by its FIFA confederation. While random bucket coloring is also possible for this example, creating buckets gives us more control over coloring and naming. For point features, the feature outline color is another opportunity to display information. Let's display each city, state, or province using a random outline color. Let's also increase the outline width to make the outline color more visible. The outline color legend now shows in the tree view below the fill color legend. We can expand the outline color legend to show each state or province, with the associated outline color. For point layers, the point size is another excellent opportunity to display a facet of information for each city. Here we will use the city population to size each data point. We will create 4 buckets for city population: large, medium, small and tiny cities. Just like fill color and outline color, the size property presents a legend of each size bucket, displaying both size and name. Labels are another powerful means to show multiple data values for a single data point. Let's add the city name as a label for each data point. Just like all other map objects, labels are rendered inside the tree view. Let's give this label a descriptive name. Here we will select Dynamic Label Text, since we want the label text to be data-driven from Power BI data. Just like a layer, a label can have multiple properties that require separate legends inside the tree view. Here we will set the label text legend title to be more descriptive. For most scenarios we will choose distinct to have the label show values from columns or expressions. It is also possible to create buckets of label text if raw text values need to be replaced by more descriptive terms. By default, labels will render centered on the data point. Let's move this label up above the data point so the two do not overlap. Label offset values are in multiples of the label size. The city name label is shown under the Labels section. Unchecking the Labels section will hide all labels, while unchecking individual labels will only hide those labels. Let's also add the population as another label below the data point. This label will show the value of an expression instead of the value directly from a Power BI field. Here the population numerical value will be prefixed for better clarity when viewed on the map. Just like labels, images can also be added to convey more information about a data point. Here we will show an icon for each city that has hosted a Summer or Winter Olympics. Because Beijing has been selected to host both the Summer and Winter Olympics, we will allow for the capability to show both icons at the same time. We will use a TypeScript function to create an advanced expression that will indicate whether a particular city is a Summer or Winter Olympics host. We will then create a bucket and drag and drop our icon into the bucket value from an image on our hard drive. For images, the offset value is the number of pixels from the data point. Here we see an indicator for each city that has hosted a Summer Olympics. The indicator is offset from the data point 40 pixels above and to the right of the data point. Just like other map properties, image properties such as the URL property will show all bucket values as a legend, and when expanded, will show all the features with that bucket value. Let's repeat the exact same procedure for the Winter Olympics indicator to complete the example. Notice that the expression window shows error notifications when your expression contains an error. Here, the single quote requires escaping using a backslash. Now both the Summer and Winter Olympic indicators are shown on the map next to applicable cities. Images can also replace data points as the visual indicator for the feature. In this example, we will add an indicator image to the data point layer, and reduce its size so it will not overlap when multiple cities are close together. We will also implement image recoloring, so the image color will still show each city's FIFA confederation. Here we specify the color we would like to replace, and the tolerance we would like to apply when replacing the color. A 50% tolerance is normally a good start. Just like we did for the data point fill color, here we are creating an expression that specifies which FIFA confederation the city belongs to. We will then create buckets for which color each FIFA confederation should display. Here we recreate the color scheme for each FIFA confederation to match the colors we had previously for the data point fill color. The original image is too large to use as a city indicator, so let's shrink it down to an appropriate size. Here we want to hide the data point that comes with the Power BI layer. We do this by setting the data point size to 0. Now all cities show the image indicator instead of a circular data point. But the indicators are not clickable like the data point were. Let's fix this problem by setting the indicator image as the interactive object for the Power BI layer. One of the core features of the layered map is the ability to show multiple layers on a single map. Let's explore this functionality now by adding a WMS and WFS layer to our map. Here we are going to add a WMS layer from the National Oceanic and Atmospheric Administration that shows current weather patterns across the United States. Here we are going to add a WFS layer from the default GeoServer implementation that shows the lower 48 states. Let's set the title and folder structure for these new layers. Note that the / indicates the start of a subfolder. Let's change the order of the layers so that the lower 48 states is the lowest layer, followed by the Power BI layer, followed by the weather map. Because the lower 48 states is a WFS layer that shares a data value with the Power BI dataset, we are able to join the Power BI dataset to this layer for an enhanced interaction. Here we will choose the field from Power BI and the field from the WFS layer that share a data value. To demonstrate the enhanced interaction that joined WFS layers allows, let's again add a table to the report page. Now we can click on a state from the WFS layer to show all the cities inside that state. We can also filter out all states from the WFS layer without any cities. This completes the grand tour of the Power BI layered map visual. For more information, videos and examples, please visit powerbilayeredmap.com.